Hey, my algebra students. I am just going over these quizzes because I know we have a big test this week, and I just wanted to review the quiz with you as you are, I know, finishing up your study guides, which are due Monday and Tuesday. We're going to go over them in class, and then I will post a video. I just want to make sure everyone is going and doing the work first before I post the solutions, because it's not helpful when people don't do the work and then just copy the answers, right? So we want to actually do the do. So let's take a look at these quizzes because I'm sure these will help you with your study guide, right? So on number one, quiz one, back in the day, number one said, does the following table represent a linear function? And linear functions means that we have a constant slope or a constant rise over run, which is the same thing as saying we have a constant change in our x values and our y values. And because this goes up by 3 every time and this goes up by 4 every time, we can say yes, it is a linear function because there's a constant change in x and y values. Of course, they could have gone down as well. It just means that it is a constant slope, right? Number two, said to make a T table, use a T table. This is a T table, literally the letter T here, to find our x and our y intercepts. And we know we find an x intercept when y is 0, and we find a y intercept when x is 0. So if y is 0, well, then it gets rid of this value and you just have the equation negative 3x equals negative 27, and you divide and get 9, right? And the same goes that if I have solving for the y-intercept, if x is 0, then I literally have the equation 9y equals negative 27, and I divide by 9 and I get negative 3. So that's my x and my y intercepts, right? On this graph, it says, what's the x-intercept? Well, we know it's when it's intercepting on the x-axis. So obviously, it's negative 2. And then it asks for the y-intercept when it's colliding on the y-axis. And of course, that's when x is 0. So it is going to be hitting on the y, which is 4. Now, when we do y equals mx plus b, our y equals mx plus b, our y-intercept is the b, right? So once we solve for the y-intercept, these two are the same things, right? It's both equal to 4. And then our m is our slope, which is our rise over run. And we can see we're rising 4 and running 2. So 4 over 2 equals 2, and our slope is 2. Right? And then we write the equation of the line, and y equals mx plus b, which is y equals 2, our slope, x plus b, which is our y-intercept, which is 4. On 4 and 5, it asks for the slope of the line. When we're not given the slope on the graph, how can we figure out what the change in y over the change in x looks like? Well, we use our slope formula. We literally have the change in y over the change in x, right? And we can label our points. This is the first point, and this is the second point. And then we can plug in our values, y2 minus y1 over x2 minus x1. We get negative 3 over 2. So the slope is negative 3 halves, right? On the next one, we have our y minus our y1 and our x2 minus our x1, and we get negative 2 minus a negative 2, which means we add them all, right? Because we change a negative to a negative. We always make everything to be an addition, so we change this symbol, so we change that symbol. And so we end up with 0 over 5. And this means it's a 0 slope, not an undefined slope. If we're not sure, we could just sketch out these points, kind of very sketchy. Number 1 is that 1 and negative 2, that point would be there. And then the second point would be 6, negative 2 would be there. We connect these lines. We can see that it is indeed a 0 slope, right? Because if we had a line that went the other way like this, that would be called undefined. defined, right? And that would be if we had, say something, a number, right, divided by 0. That's always undefined. We cannot divide by 0. All right, quiz number 2. Number 1, we had to graph, and I could have chosen to graph using my x and y intercepts. If I were to do it that way, I would have had to move this value over there. So I would have 3x plus 5y equals 15, and I would use my x and y intercepts, and I would have gotten that the y-intercept is 3 and the x-intercept is 5. And you can see by graphing on here, my y-intercept is indeed 3 and my x-intercept is indeed 5, and I would have graphed it that way, right? This is using intercepts. But I chose to divide everything solving for y because I wanted to graph using y equals mx plus b. So I get my y-intercept is 3, and my slope is negative 3 over 5. So that means I have to go down negative 3 and over a positive 5. And I draw my line. Number 2 says to put the equation in point slope form. If I'm given a point and a slope, I always use the point slope form, which is right here. I have y minus y1 equals my slope times x minus x1. This helps us prepare for algebra 2. We've talked about that a little bit. So I have a point and a slope, and I put in the correct values. Here's my point y, which is negative 5, and my x, which is 1. So I end up with y minus negative 5, and negative becomes a positive, and x minus 1. And then so I just kind of simplify this, and I get my point slope form. Now on number 3, I use the point slope form because I'm given a point and a slope, and I'm trying to solve for slope intercept form, or y equals mx plus b. So I put it in that form, and then I solve for y. I distribute the 2, and I isolate y, and I get y equals mx plus b, which is y equals 2x minus 1. And number 4, we write the equation in slope-intercept form that contains these 2 points. So now I don't have a slope yet, right? So I need to use the slope formula to first solve for the slope, and then I can choose either of these points because the line contains both of these points, and I just need a point and a slope. So 1 point and a slope, which we just solved for. So it doesn't matter which point we use. I chose to use this one because it seems easier to use 1, 1. So I solve for my slope, which is negative 3. Then I use my point slope form, in that I use this point and this slope to get the equation of my line, which is y equals negative 3x plus 4. And the last quiz that we did last week, first we graph using y equals mx plus b. My y-intercept is 2, and my slope is a negative 1/3, and go down 1 and over 3. And it's you can see it's a negative slope right here, and this starts in the negative quadrant and ends in the negative quadrant, so that's always a nice little check. On number 2, again I'm solving for y to graph using y equals mx plus b. I see the y-intercept is negative 3, and my slope is up 3 and over 5, and it's a positive slope, and you can tell that because it ends on a positive line. We're good. Okay. Number 3 says to write the slope intercept form of the given information. Again, we're practicing this another time. We are given a slope and a point. So I use my point slope form, and I plug in y minus y1 and times my slope times x minus x1 right there, and I solve for y. I get negative, and negative is positive, so y plus 2 equals, and I distribute here, 2x minus 2, isolate my y using my inverse operation, getting y equals 2x minus 4. Next, I do the same thing, but I first have to use my slope formula to solve for my slope When I do that, I get 2, and then I use a point and a slope. This time I chose to use this point, and finally I get y equals 2x minus 8. The last question I have on here is about parallel and perpendicular slopes. And parallel lines have the same slope, which is pretty understandable, because if I have a line going this way and I have another line, different color, that has the same slope, right? If they're both rising and running the same, they'll never touch, and we call that a parallel line, so it's always the same slope. If I take that slope, though, and I do the opposite, so if I go to positive to negative, or from negative to positive, and then I also do the reciprocal, which means the reflipical, I flip it upside down, I get the opposite reciprocal slope. So when I do that, so if let's say I have this point right on here, and I choose to do the opposite slope, let's just say this was 1 over 1. If I choose to do opposite, so from positive 1 would be to negative 1, and then if I have 1 over 1 and I flip it over, I'm still just negative 1 over 1. So if I do that, then I go opposite reciprocal, up 1 over negative 1, or down 1 over negative 1, right? You can see that I end up with a perpendicular line from these two lines. So opposite reciprocal slope. Alrighty, tomorrow we will go over the study guide. Please have it done when you walk into class. There is no homework passes. There are no homework passes for any of the study guides. It's in the syllabus. Please have it done when you walk in. Don't forget, I am at school about 7 o'clock, so if you ever need help, I'm there, and I'll be there at lunch too. Okay, see you tomorrow.